Hello everyone, and welcome to Earth Archives. France in the 18th century was a time filled with incredible mathematical miracles, almost like an adventure where time and space intertwined, with mathematicians shining brightly across the land. Back then, the world of mathematics resembled a dazzling starry sky, with each star representing an outstanding genius, and one of them, without a doubt, was Legendre. His name might not be as well known as Newton or Euler, but in the vast river of mathematical history, his contributions are still undeniable, and it could even be said that his influence, in some ways, was more profound than that of many other giants of the time. When we mention Legendre, what often comes to mind first is his deep exploration of some of the most fundamental topics in mathematics: mathematical analysis, algebra, and number theory. 18th century France was a breeding ground for scientific innovation, with mathematicians like Riemann and Gauss constantly pushing forward new theories. However, Legendre was not just a traditional scholar standing on the shoulders of giants. In fact, he was known as a transitional mathematician because he not only inherited the work of those before him, but also bravely challenged and pioneered new ideas. The challenges and achievements that Legendre faced made him an indispensable part of the mathematical world. His contributions are like a beautiful melody that echoes through the history of mathematics. Whether it was his passion for academics or his perseverance in scientific exploration, he became one of the brightest stars of his time. 17th and 18th centuries, the brightest era in the history of mathematics. In 18th century France, the brilliance of mathematics seemed impossible to overshadow. This period saw France become the global center of mathematics, attracting countless mathematical giants. Imagine such a small country being able to nurture so many mathematical prodigies. It's truly awe-inspiring. Historical records of mathematics from that time mention 36 great mathematicians, nearly 20 of whom were active in the 17th and 18th centuries, with 10 of them hailing from France. The names of these mathematicians are still widely revered today, whether it's Lagrange, Laplace, Monge, Fourier, Cauchy, Descartes, or Galois. They were the top figures in the field of mathematics, leading innovation in various domains. The presence of these mathematical geniuses seems like a clever arrangement of fate, with mathematical ideas colliding and intertwining between them, sparking endless creativity and challenges. This made the era a golden age in the history of mathematics, filled with passion and innovation. You can imagine them in the coffee houses or study rooms of that time, discussing the mysteries of mathematics, inspiring each other with new ideas. Behind these great names were brilliant theories and breakthroughs that overturned old concepts. Whether as mentors and students or as collaborative friends, these mathematicians left a rich legacy in the history of mathematics. However, despite such a dazzling array of stars, there was one brilliant star that perhaps did not receive the recognition and honor it truly deserved. His name was Legendre. Although he was not included in the pantheon of mathematical masters, his position in the history of mathematics is equally undeniable. Legendre's achievements may not have been as groundbreaking as Laplace's or as illustrious as Lagrange's, but his contributions to mathematics were of irreplaceable importance in many fields. Legendre's talent and perseverance made him a transitional mathematician of his time. Instead of directly challenging the most monumental mathematical problems, he chose to quietly blaze new trails in different areas, particularly in number theory and mathematical analysis. His Legendre polynomials, which are still used in many mathematical problems today, were not only a deep exploration of mathematical theory, but also contributed to significant research such as Gauss's error theory. This work had a profound impact on the development of fields like statistics and physics. Legendre's early life. Pierre-Simon Laplace, the French mathematician and astronomer, was undoubtedly one of the brightest jewels in the scientific world of the late 18th and early 19th centuries. His story is filled with profound understanding of mathematics and physics, as well as an unrelenting spirit of exploration. Born in 1752 in Paris, Laplace came from a wealthy family, which provided him with exceptional educational opportunities, allowing him to be exposed to mathematics, physics, and other natural sciences at an early age. This laid a solid foundation for his future achievements in the scientific community. As a young man, Laplace displayed extraordinary mathematical talent. His academic journey started off smoothly. At the age of 18, he wrote a paper that successfully passed academic review, officially marking his entry into the mathematical academic scene. This paper not only signified the beginning of his mathematical exploration, but also made him stand out in the academic world. It was during the golden age of mathematics, when luminaries like Euler and Lagrange were active, and Laplace quickly became an indispensable part of that era. His research spanned a wide range of fields, from mathematical analysis and number theory to astronomy. Among these, his most well-known contributions were in the field of celestial mechanics. His book Celestial Mechanics can be considered one of the most authoritative works in astronomy at the time, further developing and refining Newton's theory of gravity. Laplace's mathematical achievements had a profound impact on the development of later mathematical theories and scientific progress. Particularly, his in-depth exploration of gravitational theory provided an important theoretical foundation for subsequent scientists, not only advancing the field of physics, but also leaving a lasting influence on the development of astronomy. The Call of the Stars. In his youth, Pierre-Simon Laplace often found himself gazing up at the star-filled sky on peaceful nights, feeling the vastness and boundlessness of the universe. For him, this endless sea of stars was not an unreachable dream, but a realm full of infinite mysteries, waiting to be unraveled. His yearning for the profound beauty of the cosmos not only sparked his interest in mathematics, but also ignited his infinite curiosity about astronomy. Every star in the sky, every orbital path of the planets, kindled in him a deep desire for answers to countless questions. Laplace was not merely a mathematician. He was one of the earliest mathematicians to apply modern scientific knowledge to the exploration of the universe. At the time, astronomy was still in the early stages of classical physics, and most of the understanding of planetary motion relied on observations and intuition. However, Laplace knew that only mathematics could provide the key to a deeper understanding of the universe. He systematically studied phenomena like planetary motion and the mutual gravitational attraction of celestial bodies using mathematical methods, a groundbreaking approach in the scientific community at the time. His mathematical research, especially in celestial mechanics, combined Newton's theory of gravity with mathematical methods, creating new perspectives and promoting the theoretical development of astronomy. Laplace's contributions were not instantaneous. Rather, through meticulous calculations and reasoning, he gradually revealed the laws governing the universe's workings. His research had a pivotal influence on later scientists, especially on the work of figures like Gauss and Laplace. For example, Laplace's studies of celestial motion not only helped determine the shapes of planetary orbits, but also explained the role of gravity in celestial motion through mathematical models. These works laid the foundation for later theories of planetary motion. His book Celestial Mechanics delved into the core issues of astronomy and applied mathematical tools to various aspects of the field, establishing him as one of the most important astronomical mathematicians of his time. Laplace's mathematical breakthroughs. Laplace's mathematical contributions truly transcend the ages, and they continue to have a profound impact on today's daily life and scientific research. His academic achievements are not confined to the realm of mathematics, but extend to physics, astronomy, and various other disciplines. Particularly notable is his innovative mathematical methods, which remain cornerstones of modern science. Among these contributions, one of the most influential is the method of least squares. In simple terms, this method is used to solve the problem of finding the best fitting line or curve for a set of data points. Specifically, The core idea of the least squares method is to minimize the sum of the squared differences between the data points and the fitted line, thereby finding the optimal fitting curve. While it might sound abstract, the application of this method is vast, ranging from simple data fitting to complex statistical analysis. Returning to Laplace, he played a pivotal role in the development of the least squares method. At the time, there was no systematic method in the mathematical community to address such problems. Laplace's innovation not only enhanced data processing, but also paved the way for the development of later fields like statistics, regression analysis, and more. Even today, the method of least squares remains one of the most widely used data fitting techniques in fields such as data science, machine learning, and economics. Whether used for predictive modeling or precision analysis, it plays an indispensable role. The birth of the method of least squares. The method of least squares, this world-changing mathematical technique, was originally proposed by Laplace. At the time, scientists faced many errors and uncertainties when measuring celestial movements and predicting the trajectories of stars. Laplace understood that in order to find the best fitting line that most accurately represented the real world from a set of chaotic data, it was necessary to design a method that could minimize these errors. Thus, he introduced the method of least squares, which works by minimizing the sum of the squared differences between the data points and the fitted line to find the best fitting line. This innovation quickly solved the significant challenges faced by scientists in astronomy, especially in terms of precise measurements and predictions of celestial motion. However, the development of this method was neither immediate nor unique. Soon, another great mathematician, Gauss, also proposed a similar idea. Gauss, regarded as a giant in mathematics and astronomy, possessed the talent and intuition to make discoveries and innovations in the field of mathematics. Gauss even claimed to have discovered the method of least squares before Laplace, and in 1801 he successfully used this method to calculate the orbit of an asteroid. This achievement had a profound impact on the astronomy community at the time. Such academic disputes undoubtedly sparked considerable discussion in the mathematical community. Who truly was the first to discover the inventor of the method of least squares? This kind of debate is not uncommon in the scientific world, as many great discoveries are often accompanied by competition and controversy. However, for Laplace, he was not discouraged or deterred by such debates. In fact, his attitude demonstrated his extraordinary resilience and perseverance. Whether it was the dispute with Gauss or facing controversies regarding his contributions in the mathematical community, he remained steadfast in his academic principles and continuously explored and innovated. This indomitable spirit secured his place in the history of mathematics. The academic dispute between Laplace and Gauss. The dispute between Laplace and Gauss may never have a clear resolution, especially in the long course of history, as both of these mathematical giants achieved remarkable success and had incomparable influence in their respective fields. Although Gauss is ultimately considered to have made a more profound contribution to the history of mathematics, particularly for his discovery and theoretical work on the normal distribution, this does not mean that Laplace's achievements are overlooked or diminished. In fact, Laplace's contributions to mathematics, astronomy, and statistics remain indispensable to contemporary scientific research. Particularly, his introduction of the method of least squares is still an essential tool in fields such as statistics, data analysis, and astrophysics today. Whether in modern data science or in the work of astronomers predicting the trajectories of celestial bodies, the method of least squares plays a crucial role. It not only solves the problem of finding the best fitting line amid chaotic data, but also enables complex data to be understood and processed in a simple and precise way. Therefore, while Gauss's influence in the academic community may be greater, Laplace's contributions remain a brilliant gem in the development of mathematics and science. This dispute also reveals the inevitable competition and clash of ideas in the development of science. In such disputes, Scientific truth is often not achieved instantly, but gradually emerges through intense discussions, debates, and explorations. Behind every scientific argument is a process where mathematicians, physicists, and scientists constantly challenge limits and break boundaries. It is this intellectual ferment that drives the advancement of scientific theories and propels humanity forward in both cognition and technology. Laplace's academic career and contributions. Laplace's academic achievements are numerous, with his contributions to mathematics, physics, and other fields revolutionizing the academic world at the time and laying a solid foundation for future mathematicians and scientists. His work spanned across multiple disciplines, including mathematics, physics, and astronomy, which made him one of the most influential scholars of his time and left a deep mark in the history of science. Laplace's position and achievements in the academic community were highly recognized. He held prestigious roles, such as a member of the French Academy of Sciences and the Royal Society of London. These honors not only acknowledged his individual academic achievements, but also recognized his irreplaceable position in the scientific world. His status allowed him to exert greater influence in the international scientific community and provided a broader platform for his research. One of Laplace's most representative contributions was his 1794 publication, Essai philosophique sur les probabilités, Philosophical Essay on Probabilities. This book became a classic in the mathematical community and was widely used at the time. Its publication not only marked his excellence in mathematics education, but also greatly contributed to the popularization and development of mathematics. The content of the book covered the fundamental principles of probability theory, clearly and profoundly explaining many important theorems and formulas. It had a far-reaching impact on the mathematical education system of the time and set the standard for later mathematical textbooks. In addition to his research in mathematics, Laplace's work extended to other fields, such as physics and astronomy. His research not only advanced mathematics, but also played a vital role in the progress of physical and astronomical theories. For example, his work on celestial mechanics and gravity theory provided theoretical support for later astronomers, such as Laplace and Gauss. These studies cemented Laplace's influence in these fields, and his academic contributions helped propel the development of astronomy and physics. Influence and legacy. Although some of Laplace's theories were eventually overturned or surpassed by later scientists, this does not mean his contributions lost their significance. In fact, Laplace's academic achievements had a profound and lasting impact on the scientific community, both during his time and in inspiring later mathematicians and physicists. His research methods and academic spirit became invaluable resources for countless subsequent scholars, profoundly shaping scientific thinking and the development of academic research. First and foremost, Laplace's research methods demonstrated his relentless pursuit of scientific truth. He not only had a solid foundation in mathematics, but also pioneered many new ideas and methods in the process of exploring the intersection of mathematics and physics. Whether it was his contributions to the method of least squares or his work in celestial mechanics, these achievements showcased his exceptional ability to apply abstract mathematical principles to practical problems. At the time, many mathematical theories were still in their infancy, and Laplace's mathematical vision and methods played a catalytic role in advancing the entire academic field. Although many of Laplace's theories were later surpassed or modified by scientists like Gauss and others, his academic spirit and exploratory methods remained deeply ingrained in the development of mathematics and physics. Modern scientific methods, data analysis techniques, and astronomical theories continue to bear the imprint of the foundations Laplace laid. Even though some of his specific theories did not withstand the test of time, his spirit of innovation, precise calculation methods, and deep understanding of data remain models that later scholars continually draw upon. Moreover, Laplace's contributions were not limited to his personal academic research. As a teacher and mentor, He also had a far-reaching influence on future generations of mathematicians and physicists. His teaching was not just about imparting knowledge. It was also about inspiring critical thinking. He mentored numerous students, and through his academic writings, played an active role in advancing the mathematical community and even the broader scientific development of his time. Many of his students achieved academic success under his guidance and carried forward his mathematical ideas, ensuring that his legacy would continue for generations to come. Laplace's personal charisma and interpersonal relationships. In addition to his remarkable achievements in mathematics, Laplace's personal charisma and contributions to others made him a highly respected figure among his peers. Not only was he an exceptionally talented mathematician, but he was also a generous mentor, supporting and encouraging young scholars. This made him one of the spiritual leaders of the mathematical community of his time. Laplace's care for the academic world and his dedication to supporting his juniors extended his influence far beyond his own research contributions. He was always willing to help young mathematicians with potential, offering support both in their academic work and personal development with a selfless attitude. For instance, the famous mathematician Niels Henrik Abel was one of the scholars who benefited from Laplace's help. Abel had submitted an important paper, but unfortunately, the manuscript was lost. This was a significant blow to Abel. However, Laplace did not overlook Abel's contribution. Instead, he actively helped him recover the lost manuscript and publicly acknowledged Abel's work. This action opened the door to the academic world for Abel and allowed the young mathematician's talents to be recognized globally, which greatly facilitated his career in mathematics. Additionally, Laplace also provided immense support to another scholar, Sophie Germain, a woman who faced tremendous challenges. Due to societal restrictions on women, Germain was unable to attend university and had to disguise herself as a man to engage with mathematicians. Despite these barriers, Laplace did not let her gender hinder her. He encouraged her to face the difficulties boldly. Laplace not only supported her academic achievements, but also made her research widely known. His actions not only helped Germain establish a place for herself in the academic world, but also paved the way for women's advancement in mathematics and science. Laplace, a transitional mathematician? Laplace's academic career was undoubtedly filled with challenges and controversies, and many refer to him as a transitional mathematician. This label reflects his unique position in the history of mathematics. He was both an innovator and a transitional figure. His contributions served as a bridge in the development of mathematics. While many of his discoveries were eventually surpassed or even overturned by later mathematicians, this does not mean that his contributions were insignificant. On the contrary, it was precisely his groundbreaking ideas and methods that provided new perspectives and approaches for future developments. As a transitional mathematician, Laplace's work both challenged the established mathematical systems and paved the way for new generations of mathematical theories. His in-depth research in fields like mathematical analysis, number theory, and celestial mechanics, especially his innovations in methods like the method of least squares, provided the academic community of his time with tools to solve complex problems. Although these discoveries may not have fully withstood the test of time or were further refined and developed by other scholars, Laplace's contributions still deeply influenced the evolution of mathematics. His achievements were not only theoretical, but also encompassed the promotion of mathematical education and academic collaboration. His academic spirit and guidance for younger scholars allowed his influence to extend beyond his direct research areas, playing a very important role in the development of mathematics. Although he may not have been the most revered mathematical master of his time, he undoubtedly laid the foundation for future mathematical advancements and contributed to the formation of many major theories that emerged later. Thus, referring to Laplace as a transitional mathematician is not only an accurate description of his role in his era, but also a tribute to his tireless efforts in advancing mathematics. His work broadened the path of mathematics and provided endless inspiration and insight for future mathematicians. Was Laplace born in the wrong era? Indeed, had Laplace been born in an earlier or later time, his talent and accomplishments could have made him the brightest mathematical star of his era. While this thought may be regrettable, if we look at it from another perspective, we might realize that it was precisely the intense competition with other mathematical geniuses that enabled Laplace to break through and achieve such greatness in his time. In the world of mathematics, what great minds fear most is not the lack of opportunities, but rather being isolated and unsupported. Laplace was able to leave a profound mark on the field of mathematics, partly because of the intellectual collisions and exchanges with other contemporary geniuses. The development of mathematics is not a solitary journey. Rather, it is through the collective exploration and continuous challenges from numerous scientists that boundless innovative forces are ignited. Competing with giants like Gauss and Laplace pushed Laplace to constantly challenge his limits, driving him to engage in deep research and innovation in mathematical theory. Legendre, an indelible light in the history of mathematics. Although some of Legendre's theories were eventually replaced by later scientists, his contributions still hold an unshakable place in the history of mathematics. His name will forever be associated with the method of least squares, planetary motion, and other mathematical achievements. These discoveries not only changed the scientific understanding of their time, but also paved the way for future mathematicians and scientists. Whether in data fitting, astrophysics, or statistics, Legendre's work continues to play a vital role in today's scientific research. While some of Legendre's mathematical achievements have been surpassed by subsequent theories, his academic stature remains unaltered. His research had a profound impact in its time and laid the foundation for the development of modern mathematics. The theories and methods he promoted are still an important part of mathematics education and research. For the mathematical community, Legendre was not only a giant who brought theoretical breakthroughs, but also a visionary pioneer. More importantly, Legendre's academic spirit and his support for future generations of scholars have become a model for all researchers and mathematicians. His generosity and selflessness in the academic world, along with his guidance and support for young scholars, made him a beacon in the mathematics community. Whether it was scholars like Abel and Germain or the mathematicians who grew under his mentorship, all were deeply inspired by Legendre's academic spirit. He not only passed down his mathematical talent, but also demonstrated true academic integrity through his actions. Legendre's story is undoubtedly an inspiring one. It teaches us that no matter how many challenges and controversies we face, as long as we have a true passion for science and perseverance, we will ultimately leave a lasting mark in the course of history. Although his brilliance may have been temporarily overshadowed by the light of other geniuses, his contributions to mathematics and science remain ever present, deeply influencing the scholars who came after him. The efforts made by every scientist are never in vain. Regardless of the outcome, the pursuit of truth itself is a great journey worthy of respect. This concludes today's video. If you're interested in the stories of Legendre, Abel, Germain, and other mathematicians, don't forget to continue following our channel. The next episode will bring more exciting stories and take you into an even more brilliant world. Be sure not to miss it.